As part of this lecture, let's go to the details about how to filter the data based on aggregated results. In this case, we have to use something called as having clause. Using having clause, we should be able to filter the data based on aggregated results. Let's take the task where we want to get only those dates where the count is greater than 120. You should be able to achieve it using having on top of group by. As part of having clause, we should be able to specify either aggregate function or alias. Either of the approaches will work, but you will not be able to specify the position. You have to either use aggregate function like this while comparing with 120. Let me say greater than or equal to 120. Here I am trying to get the dates where the count is at least 120. Now, if you run this, it will work without any issue. If you review the output, you can see 22 rows. Out of 364 rows, it have returned 22 rows. Instead of using the aggregate function like this, you can also specify the alias. The alias is nothing but order underscore count. Now let me select this and let me click on this to run. Okay, as part of having clause, the alias is not allowed. In some databases, it is allowed. When it comes to Postgres, I think it is not allowed. We only have to have the aggregate function like this. Now we should be able to select and run this. So when it comes to the order of execution, when we have having clause, group by and having will be executed simultaneously with select. Typically select will be executed a little bit after group by and having. That's why you have this restriction. Only position will work, but the alias will not work as part of having, which is part of group by. So having is part of group by. You cannot have having clause without group by. This is how you should be able to filter the data. Let's take another problem statement and let's come up with a query where having is used to filter the data based on aggregated results. Already we have developed a query to get revenue for each order using order items. The query is nothing but this one. Select order underscore item underscore order underscore ID, then round off sum of order underscore item underscore subtotal. Let's make sure this is typecasted to numeric so that it can be passed to round function. We need to make sure the revenue is rounded off to 2 decimals, and hence as part of second argument for round, we have to specify 2. Then we can say as, we can specify the alias for this derived field. Let me say order underscore revenue as alias. Now let me go to the next line. Let me say from, the table name is nothing but order underscore items. Then we should be able to group the data by order item order ID. Here either I can say group by order item order ID or group by 1. Then let me say order by 2 DESC. This is the query using which we can get revenue for each order ID using order items table. Let me run this and let's review the output. You can see that it have returned 57,431 records or rows. Now we wanted to filter the data in such a way that we get only those orders where the revenue is greater than 2000. We need to use having clause. As part of having, we can have this logic. Then we should be able to apply filtering on this logic. I have copied that, pasted here. Now we should be able to say greater than or equal to 2000 in case if we want to get all those orders where the revenue is at least 2000. If it says the revenue should be greater than 2000, then we have to use greater than here. But if the requirement say at least, then you have to use equal also. Now we should be able to run this query without any issue. We'll only get those order IDs where the revenue is greater than 2000. You see there are only 17 orders where the revenue is greater than 2000. This is how you should be able to use having to filter the data based on aggregated results. Make sure you are fairly comfortable with it. There is also alternative approach to filter the data. You can use subqueries, but when it comes to using subqueries for these kind of use cases, your queries will become unnecessarily verbose, which means you will be having bigger queries than required. Having will simplify. Hence, using having is recommended when it comes to filtering the data based on aggregated results.